are going to discuss the question from signals and systems given in GATE 2003 from the LTI system concept. So a sequence x of n with the z transform x of z equals to z power 4 plus z square minus 2z plus 2 minus 3 z power minus 4 is applied as an input to a linear time invariant system with the impulse response h of n equals to 2 del of n minus 3, where del of n equals to 1 at n equals to 0 and 0 otherwise. Then the output of the system at n equals to 4 is. That's what we need to find here. So coming to the solution, given that a system, given that an LTI system with input x of n having the z transform x of z and the system having the impulse response h of n and representing the output with y of n. Now we need to find the output of the system at n equals to 4. So by applying the z transform for the whole system, then it is x of z is the input, h of z indicates the transfer function of the system, and y of z is the z transform of the output. Then we know that the output is always obtained y of z is equals to the multiplication of x of z and h of z. Now already given the x of z here, now we need to find the h of z. So given that h of z is nothing but the z transform of h of n, that is z transform of 2 into del of n minus 3. So by applying the time shifting property, this is 2 into z power minus 3, the z transform of del of n is 1. So 2 into z power minus 3, and given the x of z equals to z power 4 plus z square minus 2z minus 2 minus 3 z power minus 4. Then multiplying these two, we'll get the y of z equals to x of z into h of z. This is 2 z power minus 3 of z power 4 plus z square minus 2z plus 2 minus 3 z power minus 4. Then it becomes 2 z plus 2 z power minus 1 minus 4 z power minus 2 plus 4 z power minus 3 minus 6 z power minus 7. So this is y of z we got here. Now by applying the inverse z transform here, we will get the y of n. So by applying the inverse z transform, we will get y of n equals to, this is by applying the inverse z transform, the time shifting property for the del of n gives this 2z power minus 1 like that. So we know that the z transform of del of n minus k equals to z power minus k. Then the inverse z transform of z power minus k equals to del of n minus k. Using that concept here, we can find the y of n equals to, this is 2 into del of n plus 1 plus 2 into del of n minus 1 minus 4 into del of n minus 2 plus 4 into del of n minus 3 minus 6 into del of n minus 7. Now by substituting here we need the output of the system at n equals to 4, then by substituting the n value equals to 4 in this output, then for n equals to 4, y of 4 equals to 2 into del of 5 plus 2 into del of 3 minus 4 into del of 2 plus 4 into del of 1 minus 6 into del of minus 3. We know that the del of n equals to 1 for n equals to 0 only, and 0 for otherwise. Then del of 5 0, del of 3 0, del of 2 0, del of 1 0, del of minus 3 is 0. Then finally y of 4 equals to 0, that is 0 here. So that's what the y of 4 value, that is the answer is 0.